All right, hi everyone. Welcome to the RSK Community Call for August. Good evening in Singapore. If you're in Europe or Africa, good afternoon. And if you're in the Americas, good morning. So RSKIPs are RSK improvement protocols. They're all in this GitHub repo over here. And I would encourage all of you to go check out the ones that already exist. In this meeting, and as with other community calls, we will be discussing a number of RSKIPs that are in progress. Given that the main theme of the last community call was the recent Iris release, we will be spending a short amount of time just talking about that. Also like to highlight that all the discussions related to RSKIPs, they happen in a forum as well, a discourse forum. So that's research.rsk.dev. So for example, this is the thread for discussing this call. And this is the lineup that we'll have for today. So we'll hear from John, Jose, and Sergio. So as mentioned earlier on, you can reach out to us in a couple of different ways. So there's the forum, which looks like this. It's for, I guess, more asynchronous type communications, and for more chat type questions, then you have a Slack channel. So I think the most relevant channel for that is research and innovation, but there's several others as well. It looks like this, like a Slack channel. Okay, so RSKIP 187 was a sort of meta RSKIP that grouped together all the changes that were proposed and included in the version 3 release of RSK. And if you want to see the full details of it, you can watch the recording from our previous community call at the link that you see on the screen. I think we'll paste it inside the chat shortly. What was that all about? It was the 5th network upgrade for RSK. The testnet activation has already happened, and the mainnet activation is happening later today. So this is an exciting community call because it's right before. So if you haven't already, please go here and upgrade to your latest, the latest version of RSK, which is version 3.0. It has already been upgraded to by the vast majority of miners running RSK. As you can see, we've got 96% adoption so far. So now is a better time than any. In terms of this community call, the idea is that we want to gather feedback and discuss things to do with RSK implementation, to do with consensus, etc. It has a formal process for proposing improvements. We've talked about that in detail in the previous calls, and we aim to have this every month, every 2 months, thereabouts. And of course, if there are any upcoming network upgrades like the Iris release, this is the best place to hear about it and discuss it. Okay, so with the introductions out of the way, John, would you like to take the stage? Do you have a deck that you'd like to share?
I do not have a deck.
Okay.
But I will just kind of discuss at a high level. I mean, it looks like you've got the bullet points here.
Yeah.
And share a bit about this idea. So happy Hard Fork Day, everyone. Looking forward to seeing Iris activating. With the Iris activation, we are going to be implementing a new emergency multisig, which is basically designed so that if the pegnatory nodes stop working for a period of 1 year, then all of the funds currently held in the PowPeg bridge multisig on the Bitcoin side would be sent to this emergency multisig. And that multisig is currently a 3 of 4 multisig. And I believe it's being held by Money on Chain, IOV Labs, Casa, and Adrian Eidelman, one of the core RSK core developers. And my RSKIP, tentatively number 268, is trying to propose that we expand the multisig signer set on the emergency multisig from this 3 of 4 to a 7 of 12, so that it is at least equivalent in the number of signers to the number of signers that we have on the actual PowPeg bridge. This would not be implementing an actual like full backup PowPeg bridge. So these are not POW HSM signers. These are just normal multisig signers like the existing emergency multisig. But I think that expanding the signer set to be 7 of 12 instead of 3 of 4 is just one more step that we can take to harden the emergency multisig against various kinds of coordinated attacks. Not that I believe that the current signer set would actually willingly orchestrate such an attack, but because these are not POW HSM nodes, the keys are a bit more vulnerable, and so I think the more signers that we have, the better. And expanding the signer set so that it's at least equivalent to the number of POW HSM nodes, I think is a good next step. And the main kind of implementation detail that this depends on happening first before we can move to this 7 of 12 multisig, according to this proposal anyways, is that we want to have support for Taproot in the POW HSM firmware, so that the POW HSM nodes, or rather the multisig that the POW HSM nodes are using, would be able to send the funds to a Taproot address that would build the signatures from the emergency signers using Schnorr key aggregation. So this is a new trick that is enabled by the Taproot soft fork that's going to be activating on Bitcoin mainnet in November, where the public keys that are involved in signing a transaction, like a multisig, can be like squashed together into a single key and a single signature, which introduces a great cost savings for these multi-signature transactions. And so if you're going to have the emergency multisig creating potentially lots of transactions to distribute the BTC back to its rightful owners in the case of a permanent failure of the PowPeg node, then enabling their transactions to be much cheaper than current multisig transactions using this key aggregation feature, I think would be a desirable property to have. And so this is kind of a dependency that we have before we can implement this RSKIP, is that we need to enable the current POW HSM nodes to be able to make Taproot style transactions. And that pretty much, I think, sums up the key points of this RSKIP. And I'd be happy to answer questions, or I want to point out that Sergio, who's here on the call, was kind enough to join me as a co-author. So Sergio, if you have any thoughts that you want to add before we move to questions, please go ahead.
Yeah. Thanks, John. Yeah, I think this is a good proposal for now, until we can get rid completely of the emergency multi-signature. But until that point that we are confident enough, then I think this is a clearly superior trade-off between sensor resistance and security. But I want to point out that we don't need POW HSMs to really implement threshold signatures. We just need them to do Schnorr signatures, because we can keep for any time a script where some part is using the emergency part is using threshold signatures, and that we can do in software, and the other script path is using normal multi-signatures, right, with Schnorr signatures. So we have like a step in the middle between going full threshold signatures, which is using only threshold signatures for the emergency multisig, making this path really minimal. So yeah, that's what I want to add.
Great, thanks, Sergio. And yeah, so I want to just mention that this RSKIP is still very much in the draft stage, and so for folks who have ideas about how to implement this, this it's very much, I think, open to discussion, but this is not something that's likely to be done in the next RSK hard fork, but rather the one after that, because it will take some time to do the implementation. So the RSKIP is now in the RSKIP's repo, and there's a forum thread if anybody wants to jump in and discuss how we can bring Taproot to RSK and Bridge, and also just general ideas about this emergency multi-sig proposal. Thank you, Brendan, for the time to discuss this RSKIP.
Yeah, no worries. And likewise, thank you very much for taking the time to write it. We're pretty happy to receive new quality contributions like this. And regarding like the draft status and the fact that it's work in progress, I just want to sort of point out that in the previous few community calls, that was sort of like the tempo was different, because it was in the lead up to Iris, so it was more like the status of all the RSKIPs were like more or less in a done state, because they've been in the works for a long time. But going forward, now that we've just had that major release, going forward it's going to be much more a lot of more time to discuss. We'll see RSKIPs at an earlier stage, and yeah, definitely thanks again. Okay, if there are any questions, any more questions that you think of later, please put them in the chat, and we'll try to address them at the end. Let's see. Right, next up, I believe we have Jose, emergency time locks refresh with RSKIP 207. Jose, do you have a slide deck?
No, thanks, Brendan. I don't have any slide deck, sorry. Right. But I'm going to try to explain a little bit of this
sure.
quickly as possible. So as Sean was mentioning in the past community call, and right now in a couple of hours in Iris, we are activating the RSKIP 201 that enables this safely protocol for the ERP protocol that we call. So just one clarification is that this emergency multisig won't be enabled after a year to sign all the UTXOs, but rather than that, is going to be each UTXO is eligible to be signed by the emergency multisig after a year. So this is by UTXOs basis, not the whole wallet. So the problem behind that is that we don't want those UTXOs to be signed if the POW-PEG is still working. So this wasn't covered by the RSKIP 201, and the two RSKIPs I'm going to share now are trying to help with that. So the first one, the RSKIP 207, proposes a procedure to handle all the UTXOs that we have, and it's aiming to have many UTXOs on the wallet without any performance degradation. In order for this proposal to work, we need to add a priority queue to keep track of all the UTXOs, sorted from oldest to newest, and later this queue will be used to choose which UTXOs we need to recycle. And why to recycle? Because we need to extend the delay until the emergency multisig can spend those UTXOs. The UTXOs should be recycled 6 months prior to the activation of the emergency multisig. Let's recall it's 1 year. So we have 6 months before that in order to avoid any accidental activation. And every time a new UTXO gets registered in the bridge, it should be added to this priority queue. This happens on regular pay-ins. With Iris, we are including now the flyover pay-ins. And every time a payout is performed, usually we have changed UTXOs for the bridge, and also, of course, on migrations. In any of these cases, we should add these UTXOs to the priority queue. Once we have the queue in order, in the update collections, we need to analyze if any of the UTXOs from this queue should be recycled. So the update collection is a method that is periodically called by the pegnatories, and it's one of their main responsibilities. This proposal adds a new method to the update collections called the check time lock expiration that makes a lot of things. The first of all, it uses 2 new checkpoints on the storage of the bridge to indicate when was the last time the UTXOs were recycled. The first checkpoint is by block height, and the second checkpoint, RSK block height. And the second checkpoint is a timestamp for the last time the recycling was executed. This process will now use these 2 checkpoints to verify if any of those are above a certain threshold. Let's recall, like the recycling should happen periodically. And if this happens, the process can move on. From the priority queue, it should get now any UTXOs and up to a certain amount of UTXOs that could be considered expired. Like after 6 months, we consider them expired and we need to spend them. And if that happens, the process will now generate a transaction sending those UTXOs back to the POPEG. So we are not spending them to anyone outside. It's just like a migration or a consolidation, where we are now renewing this lock time for another 6 months until the process automatically recycles. And finally, after this process finishes and when we have recycled any UTXO, we need to postpone the next recycling cycle for 2 weeks. In the timestamp, this means exactly 2 weeks. And for the RSK height, we are aiming to extend it for 40,000 blocks, which is around 2 weeks. As this proposal requires having this priority queue, we will need to make changes in all the paying methods. These are the registered BTC transaction and the registered fast bridge BTC transaction. The second one is used for the flyover protocol. These methods we have to, once a UTXO is registered, to also include it in the aforementioned queue. This should happen like we register, the pegnatories are registering the UTXOs as they are created in the Bitcoin blockchain. So they should be simply added to the bottom of the queue. But with the addition of a flyover protocol, this may not be true because we depend on the liquidity providers to register the flyover pay-ins. So we may need to include the new UTXOs in a certain point in the queue, which will have an additional cost for these methods. So we will need to change the cost of those methods to be dynamic and dependent on the data that it's sending. And in this case, will be like the height of Bitcoin to assert in which position of the queue this will go. And besides the pay-in, this also affects the payouts. And for the payouts, the idea is that we should change how we pick the UTXOs So we first pick those UTXOs that are the beginning on the queue and close to the recycling cycle. That will be it for the RSKIP 207, but there is an additional, another proposal that changes a little bit what I just shared, but I don't know if anyone has any question or comment before we move on to the next one. All right.
I think we can move to the next one.
Sure, definitely.
All right, please check out all the links. We put them in the comments in the live streams. All right.
Okay.
Continue.
So the RSKIP 264, it's just a slight variation of the 207, where, as I mentioned before, we were assuming that we may have many UTXOs, thousands of UTXOs, from where to pick which ones to recycle. In this case, we are aiming to have a consolidated wallet of UTXOs with just a reduced number of UTXOs that render unnecessary to have this priority queue. If we get rid of the priority queue, the process gets simplified a lot, because we just need to use the existing UTXOs list and sort it by addition to the storage, and that's it. We don't need to do anything else. This RSKIP implements exactly the same method I previously mentioned, the change in the update collections for check time lock expiration. It uses the same logic, but instead of using the priority queue, it simply look up on the UTXO list to pick up which of the UTXOs to recycle. This means that we don't need to make any change on the pegging methods, so we don't need that dynamic cost that I was explaining, but we will re-keep the change on the payouts processing in order to pick the oldest UTXOs before the other ones. But in order for this RSKIP to be implemented, we should change, we should try to implement any sort of consolidation of the UTXOs, and there is already a proposal to do this, which is the RSKIP 265 that I think is going to be shared later. And that's it. I don't think there's anything else to add for the 264.
Yeah, thanks very much, Jose. I don't see any questions in the chat just yet, so let's press on. And if there are any questions at the end, we'll come back to you. So next up, Sergio is going to present another 2 RSKIPs. But before we do that, let's just point out that these RSKIPs that we're discussing are linked together. So 207, right, and 264 are already linked together, right? However, if we do RSKIP 265, which Sergio will talk about right after this, then 264 will replace 207. So that's the context. And if that sounds confusing, hopefully Sergio is going to simplify that for us next. Sergio, are you there?
Yeah, he is behind the curtain. We are trying to bring it back.
Okay, maybe some internet issues.
Hello.
Just on time.
Hi. So this time I was working with 2 monitors, and I forget that the keyboard does not follow the mouse. So if I press a key in the keyboard, then I'm probably pressing in the wrong application. So forgive me for that. I just press F5, and that means, just reload the web page. Okay, let's try now.
Okay, so we'll be doing RSKIP 265 first, and then followed by 241. But Sergio, do you have your own slides?
Yes.
Awesome. Okay.
One minute.
I'll just
share screen. Okay, I'm gonna share this. Okay, do you see the screen?
No.
Yep.
There you go.
Okay. Great. First time working with the 2 screens, and this is fantastic. Okay, this is RSKIP 264, which is about the coin selection of UTXO, the consolidation and the batching of UTXOs. This time I'm going to read because there's a lot of information in this RSKIP. This is the longest probably I've ever worked on. So I want to, give you all the details. So what is the problem with the current UTXO management in RSK? So you may not be aware because there is not many peg-ins and peg-outs at this time. There's about in the hundreds. But if we reach a point that we have thousands or tens of thousands of peg-in and peg-outs, then things can get really complicated and slow for the bridge to handle all these UTXO. So these are some of the problems we have. So first of all is the UTXO denial of service, which means that if a user performing a high amount of low value pegouts can delay honest user pegouts up to 60 hours. So if a user starts sending a low value pegouts continuously in the current state, he can block the other pegouts, that the other users pegouts, for up to 60 hours, which is the round trip time that change transaction required to be signed, go into Bitcoin, wait 100 Bitcoin blocks, and come back. And so this could be problematic, even if it has a cost, because you have to pay for all these hundreds or thousands of pegouts. It's not so much, not so high cost. So we have to fix this. The other problem that we may have is UTXO proliferation. So when there are more peg-ins and peg-outs, then the UTXO set grows, leading to more CPU processing in each peg-out, more space consumed in the bridge, because the bridge has to bring from storage all the UTXO set and then store it again, because this is how it was made. And also the cost of migration. If we have to migrate one federation to another, one POPIC to another, then we have to consume all these pegouts. Another problem is UTXO fragmentation, which is every time you do a pegout, then the bridge takes one UTXO that currently is not very efficient the way that it chooses the UTXOs, and then it just slices and takes the part that is going to the user, and the other part is the change, right? But since the algorithm is not so clever, then we may be generating a lot of dust outputs, or we may be, as I mentioned in the next one, we may be distributing not evenly between the range of possible pegouts. So we may be creating too many low value pegouts and have too little high value pegouts, or essentially the current distribution of pegouts is like a Pareto distribution, and we will prefer to keep that distribution in the UTXOs amount to be able to serve pegouts with a low cost without collecting a lot of inputs each time you do a pegout, right? So we have more problems. We have the UTXO shrinks problem, which would be the opposite as the expansion problem, which is if there are more pegouts than peg-ins, then the UTXO set can be depleted. And so pegouts become very inefficient, and then we can incur in long delays of up to 50 hours, right? Because if there are too little pegouts and a number of users start consuming them, then we are out of UTXO for a certain time. Another problem is the pegout cost. So since pegouts are batched for only 3 minutes now, most pegout transactions serve a single user. So every time a pegout transaction is created, then it probably has only one output that is going to a user and a change address. So the cost of this transaction is very high. While if you could batch them or put 10 or 100 pegouts in the same transaction, then the cost would go low, would be much lower. And the cost could be even lower if we had some kind in the future, Bitcoin's future, some kind of way to aggregate signature from multiple inputs. So that could be even better. And another problem is the unfunded UTXO management problem, which is currently the bridge does not have its own funds to execute UTXO management activities for the common good of the platform. Like, for instance, if we want to do a POPEG migration, then basically we have to consume the fees from the user's funds, from the PEG, right? And even if that is a very, very small amount, it should not be consumed from the peg. I mean, the peg should always have these one-to-one funds with the Bitcoin's logs and the Bitcoins issued on the platform, okay? So even if we have a certain revenue stream that comes from transactions, executions, that goes directly to this fund, I think that we should separate a specific fund for UTXO management and do not mix that with anything. And also, if we want to do UTXO consolidation, then who's going to, and these are spontaneous, like the bridge detects there are a lot of UTXO and wants to consolidate them, so who's going to pay for them, right? So the idea is, why don't we have a fund that, you know, keeps certain amount of Bitcoin, very low amounts, for these activities? And more problems. So one problem is the varying payout costs, and this is a user experience problem. So payouts are queued, and payout transactions are built every 3 minutes. But when that happens, the payout fees are computed in that moment, because that is the moment where the transaction is created. And then the user is charged accordingly to this fee that is computed 3 minutes later, and by subtracting the amount of the fees from the payouts amount. So if I choose to do a 1 Bitcoin payout, then what I receive is a little less, because some part is spent in fees. But this is not a good user experience, because generally what I want is to transfer an exact number of Bitcoins, which I possibly I have previously agreed with the recipient, and not just a little less. So the problem is that the user does not know the exact fee is being charged. This is one problem. Like, I'm going to be charged an amount and I don't know how much is that, and the recipient will not, the destination will not know exactly what amount is going to receive. And so it would be great if we had fixed cost payouts. And the other problem is that the current coin selection algorithm does not make any attempt to refresh the emergency. This is related to the previous RSKIP. Does not make any attempt to refresh the UTXOs that are close to expire, like 6 months to expire. So this should be improved, and there should be a preference to avoid recycling at all costs. So even if you do periodic recycles, we could recycle them during payout process and not using a specific transaction. Last but not least, there is a problem of payout transaction fee bumping, right? And this is a problem that we had in the past, and we will try to solve with a new RSKIP for the next hard fork. So the Bitcoin mempool congestion produces spikes in Bitcoin transaction fees, and payout may be left waiting in the mempool for hours or days. This not only affects the user performing the payout, but also the future payout users as the bridge cannot spend the changed UTXO. So basically, if a transaction gets stuck in the Bitcoin mempool, then not only the user that commanded the payout is affected, but also all future users that may depend on the change amount of that payout. So this is another problem we want to tackle. Okay, so let's go for the easy solution. And I just want to point out that there exists an easy solution, because I'm not 100% sure that RSKIP 2065 is the right solution. I mean, I think it is, but I think that the community feedback is really important. So this is the TBTC solution. So TBTC solve these problems like saying, okay, you will only be able to peg in 1 Bitcoin and peg out 1 Bitcoin and nothing else, right? So denial of service attacks are not possible because it requires a lot more capital. If you really want to block the UTXOs, you will need to spend all the funds in the peg just to block them. There is a high payout cost. So the thing is that it's cheap to peg out, but only if you have 1 BTC, right? Only if you are going to peg out 1 BTC. And most users do not transact 1 BTC. So basically this, leaves out most of our current user base and will restrict the pegging process to just liquidity providers. So you could do something interesting like doing multi-input peggings, for instance. So basically, it's kind of coin join where you take you have to find a lot of people who wants to peg in, make them all the inputs add up to 1 Bitcoin, and then do a single pegging transaction with 1 Bitcoin. But this is kind of complex. It brings the requirement to do a protocol for finding, coin join peers, and it's really complicated. So, but there is some benefits. Like there is no problem of UTXO proliferation or shrink, because the number of UTXO just grow with the balance. So it just grow linearly. So basically cannot, it's not unbounded, it's just bounded. There is no fragmentation. There's no, well, it's not a solution for fee bumping. Like KIP network uses a special algorithm for automatic algorithm for fee bumping. There is no need for UTXO management, or yes, there is need still for UTXO management. You want to do specific activities with UTXO, but the user experience is really bad. I mean, we are pricing out all standard users and just making the system work for liquidity providers. But this is an alternative. Okay, now let's go to see what we propose. So, for preventing denial of service and high pickout costs, we propose to batch transactions, but not for 3 minutes, but for 3 hours, right? And if you think about that, the time that it takes for a pickout is about 30 hours. In the future, it will be less, but it's still a lot of time. Then 3 more hours, it's not such a big deal, right? It's just a 10% additional weight. But if the whole process goes down in time, then it will just it doesn't matter much. So now a single transaction can serve thousands of pegging users. So in 3 hours, you can collect, each pegout transaction basically could serve, it can serve thousands of peg-ins, because you just need to find the input whose amount is higher than the sum of all peg-in amounts. So you can consume very few number of UTXO and serve a lot of users. So we fix the denial of service problem, and the peg-out cost is much lower. So to prevent UTXO proliferations and shrink problems, we will do periodic consolidations or expansions. So there will be points, checkpoints every time you do a peg out, or before you do a peg out and after you do a peg in, where the bridge checks the number of UTXOs, and if it goes above a certain threshold, or it goes below another threshold, then it will trigger a specific transaction to consolidate or expand the number of payouts. And I think, and this is more like back of the envelope computation, that we would need only about 50 UTXO to be active at all times, and that's pretty enough for serving continuous stream of UTXOs, right? But what I was going to say later is that now I'm starting to do simulations to make sure that the numbers we choose, the matching numbers we choose, are really working for us. So to avoid UTXO fragmentation and the uneven amount distributions, we are implementing a better coin selection algorithm. And I want to point out that currently we are using a Bitcoin shake code for coin selection paired with a specific, coin like UTXO scoring function, so something like that. But Bitcoin shake algorithm for coin selection is super complex and it's bloated, and we don't need that. We need for consensus, we need a much simpler thing that you can just read in a single page and understand how it works. I wouldn't like to rely on Bitcoin shake code anymore regarding coin selection. So we are proposing a different coin selection algorithm, simple, easy to analyze, easy to simulate, and fix that part of the code. So to prevent this varying payout cost, we are proposing fixed cost payouts, and this is a huge improvement in user experience. The fixed cost payouts are updated every 3 hours. So every time there is a payout event, the cost for the next payout is updated. So this is a function that follows, try to estimate the cost of payout and tries to increase or decrease the payout cost for the next payout event. And this is computed using a moving average. And for the unfunded UTXO management problem, we propose to use a separate UTXO management account, which is an account in the bridge, but separated, with a feedback system to decrease or increase the amount of funds in this account, so that we always have enough funds to pay for all transactions, payout transaction fees. So we have an account that money goes in as fixed income and money goes out as variable payout fees, but we have a feedback system that updates the fixed cost so that we can always have enough funds to pay for the payout cost. So that's the idea. And this account is not very large in funds. I computed that with $500 it would be in Bitcoin, obviously, but approximately it's a very low amount of funds, but it is enough. So what this RSKIP does not solve? Well, fee bumping does not solve, and this is something I'm going to talk about later in the next RSKIP. And there is still, depending on the number of UTXOs we pick to have active at all times, it's still possible to do some kind of denial of service attack, which is basically requires, in this case, with this parameterization, 6,800 payouts. So if you do that amount of payouts, and then you can block payout for 57 hours, and you would have to pay a price of Bitcoin fees of approximately $150,000. So yeah, it's not cheap, and it's not that you block or the remaining users. The remaining users can still perform payouts, but their payouts will be delayed always this number of hours. Yeah, I think this is an expensive attack, and we can obviously mitigate it by increasing, doubling, tripling the number of UTXOs. Okay, so another possibility to improve it is auctioning payout slots. So if you want to have a prioritized payout, then you could pay more. This is another option, but I think it's complicated and unnecessary. So this is what I explained, that how the management account works. So basically, the bridge keeps a UMA balance enough to consume 60 inputs. That's the amount of funds it requires. And if the balance goes lower than this, then payout fees are increased 10% of the average. And if the balance go higher, then they are decreased 10%. But it's always plus 10% or minus 10%. It cannot grow above or below that. So payout fees, the surplus from payments in payout fees goes to the UMA, and if there is a deficit in payout fees, then that is compensated by the UMA. So it's very simple feedback system. So what about the new coin selection algorithm? So this is something that simulations will show a lot of value here. So the idea is to have first a greedy stage. This is something most Bitcoin wallets do. So I'm not inventing much here, but well, it would be interesting to simulate this. So there is a first single greedy stage where we scan all the UTXOs, and trying to find if there is a good with a good score, which means that it has an amount that is higher than the amount we want to spend, but not too much higher, because if it is too much higher, then we are blocking funds with change addresses, right? If this does not throw a good UTXO, then we get to a more smart algorithm that sort the UTXOs by amount, and then try to look at low value UTXOs, 4 low value UTXOs, at most 4, that can collect enough funds to pay. And then if that does not work, we have a more expensive one that just tries to pick the highest from the highest UTXOs, the ones that collect enough funds. So each one tries to target one efficiency problem, and the last one just picks whatever it finds. Yeah. So this is pretty easy. How is this next event payout fees computed? So there is an average that is computed over the last 24 payout events, and that average gives you the new price for the payout in the next payout event. But what is interesting is the last payment is not included in the average. So what it means is that if you have a wallet and you get a quote from the bridge, let's say, okay, the payout cost is, you know, whatever, 100 satoshis, whatever, then you know that that quote will be fixed for at least 3 hours, from 3 to 6 hours. Whether if we consider the last payout event, then it could switch immediately if there is a payout event in the middle of, you know, the query and the payout itself, right? So this forces the quote to always last at least 3 hours. So the user will know exactly how much it is paying for the payout. So what is next? So I'm starting to do simulations to make sure that all the parameters that we've chosen are good. If we find better parameterization, then we will switch to that parameterization. And we have to define the test cases, we have to code it. And the RSKIP is pretty long. It would be good to split it in 3 maybe, but that would be only a cosmetic change because each part is closely related with the other part. So, you know, maybe I do it, but it's all or nothing, right? We implement either all of them or none. Okay, so this is all about RSKIP 265. Thanks. And I think that if there are no questions, then I will be moving to the next one, right?
Yeah. I don't see any questions in the live stream chat. So yeah, let's go to 241. Yeah, you're totally right about the last one. It felt more like an umbrella RSKIP with like at least 3 different actual RSKIPs in it.
Yes. Yes, I mean, we could implement, for instance, a better coin selection algorithm and then improve it even more, like in stages. Yeah. I think it's just add more work, and we can just go for the final proposal. But yeah, this is to be discussed. And you still need to see the simulations and all, right? So RSKIP 241 is about user trigger payout.
Sergio, you're going to share your screen.
Oh, I'm not sharing the screen?
All right, we see it now.
Okay, thanks. Okay, so I mentioned before that currently, every time we do a payout, we make sure that the payout goes smoothly because we have very high byte setting. While that works most of the time, it is expensive for the users, and it can stop working, right? If there is a sudden congestion on the Bitcoin network, then the transaction can get stuck, right? And if we get to the point that they get stuck, there is still ways that we can unlock them. That we can go. There are certain mining pools that have a service for forced a transaction to be included in a block. Where I'm pretty sure they are quite expensive, like $500 for doing that or something like that. I don't remember who had this problem in the past and how much he paid, but I think it was something like that. So this could be a problem. And also there is a problem that not only the user that performed the payout is affected by a payout that is stuck in the Bitcoin mempool, but all the future users are also affected, because if this payout transaction has a change amount, then basically that change amount is in limbo until we can include it in the Bitcoin blockchain. The bridge cannot use unconfirmed outputs, right? This is a property of the bridge. There are a lot of security reasons why this is like this. It could change in the future if we implement SegWit or Taproot, but currently that's the way it is. And the deeper problem is that Bitcoin does not have a mechanism for fee bumping transactions that are not owned. I mean, where I do not own one of the outputs. So if I own one of the outputs, I can do child pay for parent, and I can spend the output and to force the parent transaction to be included. But if I don't own any of the outputs, then I can't, right? And there is no public service, where anyone can fee bump another person's transaction. There was one proposal to do this on Bitcoin, but it didn't get traction. So what would be the optimal solution? Automatic fee bumping. So automatic fee bumping is what the KIP network does, which is basically that when sometime is passed, like 10 hours or 100 blocks, and the transaction is not included, then the bridge automatically generates another transaction with higher payout amount. I think this is the way to go. We should do this. I think that before we do automatic fee bumping, which requires solving some problems, I think that we can do this manually. Like, instead of using a mining pool service to fee bump a transaction, we can just talk to the bridge and tell the bridge, hey, just regenerate this transaction. I will pay for the additional fees. And obviously that would cost much less than $500. Maybe it costs $10 to do it, right? So it's a handy mechanism for doing fee bumping. So yeah, I think I'm going to skip this because we are close to the time. This is something I talk about with the problems with child pay for parent. Okay, so what are the methods that the bridge could do to do some automatic fee bumping? Well, let's say that if currently paying transactions are registered after 100 confirmations. So the first problem is that automatic fee bumping would only happen after the bridge notices, and this would be really late, right? We will have to wait 10 hours or 16 hours only to realize that there was no transaction inclusion. But at the same time, it brings a potential attack where people would prefer not to include the transaction to fee bump it, right? It's kind of yeah. So there is a vulnerability. Potential vulnerability is that if you do a fee bumping with the different UTXOs, then basically this can be used to double spend, right? If the bridge does not record which UTXOs were used, and then when it creates the fee bump transaction, it just creates a new transaction with new UTXOs, then of course that could be used to double spend and pay double to the user. So yeah. So the solution to this problem, which is kind of obvious, is to reuse the same UTXOs, right? And why not add more UTXOs? Let's say that the original UTXOs are not enough to cover the extra fees. The problem of adding new UTXOs is that, let's say that every 10 minutes the users, the bridge or the user commands a fee bump, and every time the bridge adds a new UTXO to the set. So the transaction is a double spend because there are shared UTXOs, but the bridge is adding more UTXOs. So the problem is that all those added UTXOs become blocked, because until you know which one of these versions of the transactions is included in Bitcoin, all the UTXOs that you try to use are blocked, right? So the thing is that we cannot add more UTXO. We just have to stick with the same UTXOs that were used, which means that when we pick the UTXOs, we have to pick ones with some additional gap, some additional amount to fee bump in the future. Okay, so what is the manual implementation of fee bumping? I propose, because these methods are really quite simple, so it maybe takes more time to tell this than it takes to code it, right? So I propose to use 3 methods and let the users pick which one they want. So the first one is called fee bump. This is a new method for the bridge. Just recreate the transaction, but adds more funds to the as a fee, and the funds that are added are the message value. So if I pass some RBTC to these methods, fee bump, that's why it's payable. I give the bridge the transaction that it has to regenerate, so the bridge knows it, and then it just adds the bitcoins I sent to the method. It adds to the transaction and commands the pegnatories to sign the transaction again. Then I propose this other way, that is fee bump with input, where the user brings an additional input which is pre-signed and say, okay, if this transaction cannot, if there is no fee to fee bump this transaction, then I will give an extra input to compensate for the missing fees. And so the whole input will be consumed in fees, right? So this is a last resort method. And then we have the child pay for parent way of doing this, which means that I propose a pot from these transactions, like a price for anyone to include it in the Bitcoin blockchain. And what the bridge does, it creates a new output, which is anyone can spend output, which has this price for anyone to pick that and use that output to push the transaction into the blockchain. And so it's kind of a price that any user can take to include the transaction. So you just pass the amount of RBTC you want to put as a price, and it creates a transaction for you with this anyone can spend output for child pay for parent. So why not just doing this, adding this child pay for parent for any payout transaction? Because it just bloats the UTXO set, because we don't expect this output to be used. So it's basically creating dust in the UTXO, on the Bitcoin UTXO set, and it's just wasting funds. So we are only going to create that output if the user requires that for fee bumping, which would be very rare event. So what's next? Just define the test cases and code it, which probably can be done in a day or a couple of days. That's all. I thank you very much. And if you have questions.
Yeah. All right. Thanks. That was not mind-blowing. I'm not sure about coding it up in just a day, though. To be determined. Okay, I'm just going to quickly put my my screen up. Is that on stage now? Can everyone see it? Not yet.
I have a quick question for Sergio.
Go for it.
So I'm not sure whether it was the RSKIP you just discussed or the one before this, but is one of the kind of main changes that are happening there is that rather than having a kind of fee minus model, the bridge would kind of switch to a fee add model, where rather than reducing the fees from the amount that are being pegged out, it would add the fee on top of the amount that's being pegged out.
Yeah, the idea is that you can query the bridge and ask how much fees I'm going to be charged, and then you can add that to the amount. So the end result is the same. Like, it will subtract the fees from the amount you send, but since you know in advance how much is that, you can just add it. So if you want to send 1 Bitcoin, you just send 1 Bitcoin plus the fees, and it will receive on the other side just 1 Bitcoin.
Okay, and would there be like some sort of timeout method? Because the fee might, adjust if you wait 5, 10, 20 minutes, something.
Yeah. So the idea was, if we have time, we make this automatic. which is not explained in this RSKIP. This RSKIP just explains the method that we are going to use and a manual way of doing this. Like anyone can call these methods to fee bump any payout transaction, right? So the next step is could be for the next hard fork or for the future hard fork is to do this automatically. If we do this automatically, then we will have to create a new method to inform the bridge if one transaction has been included, but this method would inform for without waiting 100 confirmations, right? So you will tell the bridge, yeah, it's there has been 5 logs and it doesn't happen, so the bridge could fee bump the transaction. So it will be much more interactive with the bridge. But I thought that starting with a manual way of fee bumping, it's enough for now, because it happened only once in the history of RSK that one transaction got stuck. So let's first do the easy thing, and then if we need more, we just do automatic.
Got it. Thank you.
Brendan, you're muted. You're still muted.
Brendan? We cannot hear you, Brendan.
Sorry about that. Okay. So, yeah, one thing I'd like to point out is that these RSKIPs, they're still in discussion stage, and all the more it's important that we go onto the research forum, research.rsk.dev, and find the RSKIP number that you want to. There's a thread for each one. Go ahead and ask questions there. Start a discussion. Yeah, that's strongly encouraged. All right, and I guess it's time to wrap up. We're a bit over time, so just like to mention again, as we do in every call, that RSKIPs have a process. If you want to read all about it, check out RSKIP 0 with that link over there, and you can watch our previous community calls where we go into it in a lot more detail. Also, if you have questions and answers, we don't have too much time for that today. So please put them in the research and innovation channel in the RSK community Slack, or you can put it in the forum as well. Either way works. Yeah. And of course, we have our next community call. So this link over here should bring you to it. And yeah, it'll happen either next month or the month after. So if you do have an RSKIP that you'd like to discuss or present to the wider community, this is the place to do it. And that's all for today. Thank you very much, everyone, for attending, and hope to see you all again next month.
Thanks, Brendan, for hosting and
No
all the work you do for the platforms. And thanks all for being here.
Yeah.
Thank you.
Okay.
See you next time.
Ciao, everyone.
Ciao.
Later.